People think time travel is an engineering problem. It isn't, it's a universe problem, because to go back 5 minutes, you don't just move yourself, you ask every atom in existence to rewind. And that's where things start to fall apart. Section 1, the seductive idea time travel feels inevitable, not magical, not mythical, just delayed. We look at airplanes and remember that flight once seemed impossible. We look at the moon landing and remember that leaving Earth once felt absurd. So when we imagine traveling backward through time, we instinctively treat it the same way, as a problem waiting for better engineering, stronger materials, more energy, a clever manipulation of gravity. Someday, that assumption hides something dangerous, because most impossible technologies fail when we try to build them. They explode, collapse, or simply refuse to function. Time travel is stranger. It appears to fail long before construction begins. It fails at the level of structure. The idea itself begins to crack under scrutiny. At first glance, time seems like a direction we move through. Like space, we walk forward in space. Why not backward in time? If physics allows motion in 3 spatial dimensions, why should one dimension be sacred? The seduction is subtle. If time is just another coordinate, then perhaps all we need is access. But here's the fracture line. When you imagine going back 5 minutes, you aren't just relocating yourself. You're proposing that the entire universe must return to a previous configuration. Every atom in the room, every photon traveling across space, every neuron in your brain, every distant star whose light is en route to Earth. Backward travel is not personal, it is cosmological. And that's where the engineering analogy collapses. Rockets don't require the universe to rearrange itself. Particle accelerators don't demand that entropy reverse. But backward time travel would require something far more radical, the coordinated undoing of reality's current state. Before a machine can even be designed, we run into a deeper question. Is the universe structured in a way that even permits reversal, not mathematically, structurally? Because if the structure of reality already encodes direction, if change itself has an asymmetry baked into it, then no amount of technology can override that without unraveling everything else. Time travel doesn't first confront us as a mechanical challenge. It confronts us as a contradiction. And if contradictions exist at the foundation, the machine never even gets a chance to fail. It breaks before it begins. Section 2, physics doesn't hate backward time. Here's the twist. Physics, at least on paper, does not immediately forbid backward time travel. In 1915, Albert Einstein rewrote our understanding of gravity. Space and time were no longer separate arenas. They fused into space-time, a 4-dimensional geometry shaped by mass and energy. Objects do not feel gravity as a force pulling them. They follow curves in this geometry, and geometry is permissive. When physicists explored Einstein's equations, they discovered something unsettling. Certain solutions allow space-time to bend so dramatically that paths can loop back onto themselves. In 1949, Kurt Gödel found a solution describing a rotating universe in which closed time-like curves exist, world lines that return to their own past. Mathematically, you could leave Tuesday and arrive at Monday. Latter proposals involving wormholes. Theoretical tunnels connecting distant regions of space-time suggested similar possibilities. If one mouth of a wormhole experienced time differently than the other, stepping through could mean stepping into an earlier moment. Nothing in the raw equation screams forbidden. That's the unsettling part. The fundamental geometry of space-time does not encode a strict no-return sign. It describes relationships between events, curvature, motion, but it does not build in a universal arrow pointing forward only. In fact, many fundamental physical laws are time-symmetric. Film a collision between 2 particles and play it backward. The reverse version still obeys the same equations. On microscopic scales, forward and backward are equally valid descriptions. So if the equations allow it and the microscopic laws don't object, why does backward time travel feel so impossible? Because mathematics describes possibility, not probability. It outlines what structures can exist, not whether the universe will tolerate them. Einstein's equations open the door. They say under extreme conditions, space-time can twist into loops, but equations do not guarantee stability. They do not promise that such structures can form naturally or survive quantum effects or coexist with thermodynamics. The blueprint does not ensure the building stands. So now the tension sharpens. Geometry does not hate backward time. The math is calm, which means if time travel breaks, it won't be because space-time refuses. It will be because something deeper makes the allowed unstable. Section 3, entropy is not a rule, it's a trap. If geometry opens the door, entropy quietly locks it. Entropy is often described as disorder, but that word is misleading. Entropy is about counting. It measures how many microscopic arrangements correspond to a visible state. The more arrangements available, the higher the entropy. And here is the trap. High entropy states are overwhelmingly more common than low entropy ones. A neat stack of papers on your desk can be arranged in only a few precise ways. A scattered pile can exist in billions upon billions of configurations. A hot cup of coffee represents a tightly constrained distribution of energy. A lukewarm room represents energy spread in countless possible patterns. The universe does not prefer disorder philosophically. It simply drifts toward what is statistically dominant. That statistical dominance creates the arrow of time. The reason you remember yesterday but not tomorrow is not mystical. Yesterday had lower entropy. Records, memories, fossils, photographs all depend on the fact that entropy was lower in the past. The future has not yet generated those stable traces. Now imagine traveling backward 5 minutes. To do that, the entropy of your brain would have to decrease. The entropy of the air in the room would have to decrease. The thermal radiation leaving Earth would have to reverse. Every dispersed photon would need to reconverge. Every molecular collision would need to rewind. Not approximately, exactly. Backward time travel is not like walking upstream in a river. It is like commanding the entire river system of the planet, oceans, clouds, groundwater, to flow back into its precise former positions simultaneously, because entropy is not local, it is global. You cannot lower entropy in one small pocket without increasing it elsewhere, unless you are reversing the whole cosmic ledger. And reversing that ledger would mean restoring the universe to a previous total configuration, which is astronomically improbable, not forbidden by law, just crushed by numbers. That's why entropy is a trap. The microscopic laws are reversible. But when trillions upon trillions of particles interact, the probability of coordinated reversal becomes so vanishingly small that possible and impossible blur together. To go back in time, you wouldn't just travel. You would need the universe to unhappen. And probability does not cooperate with that request. Section 4, the self-destruct mechanism. Suppose you ignore entropy. Suppose you find a way to bend space-time into a loop, a wormhole stabilized, a geometry twisted just enough that yesterday becomes accessible. You switch it on. This is where physics may refuse politely and then violently. In the 1990s, Stephen Hawking proposed the chronology protection conjecture. The name sounds almost playful, but the idea is brutal. The laws of physics may prevent time travel from ever becoming operational. Not philosophically, physically. When researchers modeled what happens near the formation of a closed time-like curve, they found something alarming. As the loop begins to form, as the path through space-time starts to reconnect with its own past, quantum effects intensify dramatically. It sees with quantum fluctuations, particles briefly appearing and disappearing in accordance with uncertainty. Under normal conditions, these fluctuations average out harmlessly, but near a time loop, they don't. As light rays circulate through the forming loop, they can stack on top of themselves. Radiation recirculates, energy density increases, quantum fields amplify. The closer you get to completing the loop, the more extreme the buildup becomes. The mathematics often points toward divergence, energy rising without bound. And in physics, when quantities blow up toward infinity, it usually signals instability. The implication is chilling. The moment a region of space-time approaches functioning as a time machine, quantum effects may escalate so violently that the structure collapses. The wormhole destabilizes. The geometry tears apart. A loop never fully forms. It's not that the universe posts a warning sign. It's that the act of creating the machine triggers its destruction. A built-in self-destruct mechanism, chronology protection, suggests something profound. Causality may not be defended by logic alone, but by instability. Any configuration that threatens consistent ordering of events becomes physically unsustainable. You don't need a cosmic referee preventing paradox. You only need quantum fields behaving exactly as they always do. Time travel doesn't fail. because someone forbids it. IT fails because the closer you get to making it real, the more violently reality resists the shape required. The machine breaks itself before it ever truly begins. Section 5, the real collapse after geometry, entropy, and quantum instability. One final possibility remains. What if time travel fails because our premise is wrong? We assume time is something that flows like a current carrying us forward. We imagine the past is gone and the future is not yet real. Under that assumption, time travel becomes a navigation problem. How do we move against the current? But modern physics offers a different picture. In the space-time framework that grew from Albert Einstein's relativity, the universe can be described as a four-dimensional structure. All events, past, present, future, are embedded within it. There is no universal now slicing cleanly across the cosmos. What counts as present depends on motion and perspective. From this viewpoint, time does not pass. Events simply exist at coordinates. This is often called the block universe perspective. The universe is not unfolding like a story being written. It is more like a completed manuscript, every chapter already part of the structure. If that is true, then backward time travel becomes conceptually strange. You are not rewinding a film. There is no cosmic playback mechanism. There is only a static arrangement of events linked by causal structure. Your experience of motion through time, the sensation of becoming, may emerge from entropy in consciousness. Your brain stores records of lower entropy states, giving you memory of what you call the past. You do not have records of higher entropy states, so you call them the future. The arrow may belong to you. In that case, asking to go back may be like asking to move to a different location in the block. But every event in that block already includes all its causes and effects. If you appear in 1995, your appearance must already be woven into 1995's structure. There is no rewriting, no alteration, no branching freedom. The timeline does not change because it was never evolving to begin with. So time travel doesn't collapse because it's outlawed. It collapses because the very idea assumes time is a dynamic river rather than a geometric landscape. And if time is not flowing, if it simply is, then there is nowhere to travel.